like, subscribe, press the bell icon for more updates. For more videos, download our app from Play Store. Faculty Diploma Program. Welcome to 4th session of Machine Learning and Data Science using Python.
We'll do some recap, whatever we have covered in our last 3 sessions. We started with the introduction, then we did some hands-on coding on NumPy and Pandas, and we did perform some exploratory data analysis. Then we learned Python fundamentals. In last session, we started classical machine learning algorithms. In that, we started with linear regression, and we did EDA on house prediction data set, and we perform linear regression. And we understand mathematics behind linear regression. We did understand what are the equations we use to implement linear regressions. Now, in last session, as I told you, we covered linear regression. In today's session, we have a logistic regression. Logistic regression, that is another classical machine learning algorithm, comes under the category of supervised learning. So, what linear regression did? It predict the continuous output. For just a minute, okay, just let me share my. Okay, I hope screen is visible. So in last session, in linear regression, what we had data in the form of linear form. Okay, and what we try to do, we try to predict this data in the linear form. It goes like this. Okay, and for example, we had few columns, or we have few features in our data set where we had the distance from the sea, then area where it's in what is the population, how many number of rooms are available, and then we predict the price of the house. So this is what we did in linear regression. Now in logistic regression, what we are going to do, logistic regression, we use it for a classification. Now, I have already explained you what is the difference between classification and regression. Regression is something when we try to predict a continuous variable. Continuous variable means it might be a number. It can be a number. It can be a, for example, price of your house. It can be a stock market evaluation. It can be a weather or weather prediction. In logic, and what is a classification? Classification means you have two things. For example, you have 1 and you have 0. So classification, now there will be a certain data points that will be available with you. Now you have to classify this. All the data points belong to class 1 or they belong to class 2. So this is what a basic understanding of classification. Now what we are going to do, we will understand a logistic regression. I hope my screen is I hope the screen is visible. I'll.
Yes, it is visible.
It's visible. Yeah. Okay. So now, what is a logistic regression? So it's similar, supervised. It's as I already told you, it's a similar algorithm like linear regression used for the classification, comes under the supervised learning technique, and we we predict the categorical features. We predict the categorical features using linear regression. For example, there are certain applications of logistic regression. For example, somebody have a cancer or somebody not having a cancer. Then, for example, this particular flowers belongs to category A, category B, category T, category C. So this all sort of classification applications are with are comes under the logistic regression. So now logistic regression, it's I don't okay. Now, so basically I'll put a diagram for logistic regression so you will understand. So we do have a graph and we have certain data points now. Okay. Now, as we already discussed in our last session, in machine learning, when we submit a data to an algorithm, we do perform scaling, we do perform normalization. Why we do normalization? To save a computation resources and or do a faster execution without changing a meaning or without changing a logical meaning of that particular variable. So this entire data now we have to find out whether this data is belong to class 1 or class 0. So how we'll find out? So logistic regression comes with an equation, or you must have heard about uh, sigmoid function. Okay, sigmoid function is a basic or is a fundamental logic behind logistic regression. Now I am going to explain you what is sigmoid function and how you will be using sigmoid function for performing a logistic regression. So a sigmoid function is basically a mathematical function which we use to predict the probabilities. Now, and why I have mentioned here, if you can see this graph, why I have mentioned here 1 and zeros. So sigmoid function basically it maps any value into another value within the range of 0 and 1. As I told you, we do normalization and scaling. Okay, so and so this whatever the value are generated by sigmoid function cannot go, sorry for this mistake, cannot go beyond the limit of 0 and 1. So what happened, so due to which if the value cannot go beyond 0 and 1, so sigmoid function basically creates an uh, diagram like this. They called it as a S-shaped diagram. So this is your 1, this is your 0, is x-axis, and this is y-axis. Now this is your mid value. So I'll explain you what is threshold and mid value. So this is a kind of sorry. Yes, okay. So this is a kind of shape that your sigmoid function generates. Now, whenever you submit certain data points to your algorithms, so what your algorithm will do? So your your algorithm will calculate the values of 0 and 1 using your sigmoid function by inputting all the data points. Now, how it will get an input from data point, that we'll be saying Pythonically while the implementation of this algorithm. So what it will basically do? So it will classify the observation in a such a way that, for example, if your value is above 0.5, then it belongs to class 1. So for example, your class 1 value will be here and your class 0 value will falls here. Now, and what happens if your values which are exactly on line 5? Now we'll understand one by one what this entire diagram is telling us. So basically, so this curve that you are saying, this curve uh, is a logistic function which indicates the likelihood of something. For example, such as for example, we or for example, ca- likelihood of cancerous cells. Okay, so for example, if you have a cancer, or if certain person have a cancer, then it will all the cells which are predicting that it has a cancer, they must be having certain numeric value. So they will be all will be here, they will be grouped here. Okay, that's why their value is above 0.5 or above threshold. If they are not cancerous, then they'll do their behavior will be exactly opposite. They'll be not, they'll fall here, the group will fall below the 0.5 threshold. So this is very basic. Now this is very basic algorithm for classification. Now it also this value that we are seeing now, whatever 1 and 0 values, between 1 and 0, all the values will be in the form of probability. So it will be all the values, those, just a minute, let me minimize this. All those values will be here, will be in the form of probability, that will be in under the brackets of 0 and 0.5. So for example, this point we call technically, it's your threshold value for your logistic regression. Then for example, this is your y, that is prediction value, is if it's 0.8, and if it's y, if it's your prediction value is 0.3. So if your algorithm predicted the y value is 0.3, then it's belong to class 1. If your algorithm predicted y value is 0.8, then it's belong to class 1. It's above 0.5, then it's belong to class 1. Now what are the values that are on the threshold line? So in terms of logistic regression, we cannot do anything for this online value. Those are unclassifiable. So that is one disadvantage that comes with a logistic regression. Uh, that comes with the logistic regression. Now, what are the applications and where you can use this classification problems? And as you understand that we are only doing two classes here, that is 1 and 0. So we call this problem as a binary classification problem, because we have only two classes. So this is binary classification. So now there are certain types of logistic regression as well, such as if there are more than three classes, more than one classes, sorry, more than three classes, then there is a multinomial. There are three types: binomial, where only two classes will be there. There is a multinomial, there will be three or more classes will be there, and there is ordinal. So ordinal logistic regression, there can be three or more possible order types of dependent variable. Order types of dependent variables. So just three or more classes. Order type. Order type means something which are representing quantities. For example, low, medium, and high. So this is basic, and this is basic understanding of logistic regression. And if you if you want to see a real time applications of any classification problem, And then there is a very famous case study of classifying emails as whether the email you receive from certain user is spam or not spam. That is also one of the applications of logistic regression. So that case can be solved by using logistic regression, because we have two classes, and we do have only two classes where we have to sort it out all the sorted. So we have to classify email whether it's spam or not spam. So this is a basic outline of logistic regression. We do have a coding session on logistic regression as well. So this is very basic understanding of logistic regression that we have. So right now what I'll do, I'll share. So as last time, we follow the outline of explaining the algorithm first, um, not detail, and we explain very abstractly. Now what we'll do, we'll understand everything, how everything goes through programmatically, and how we are going to implement this Python, this logistic regression algorithm for class one classification problem. We'll see a basic binomial classification, and then we'll generate one more case study as we generated for house price prediction in last session. So we'll use one more data set here, and we'll try to perform EDA, and we'll do we'll implement a logistic regression on that. And after logistic regression, we do have one more regression and classification algorithm, that is KNN, K nearest neighbor, that will also cover. So so please open everyone their Jupyter notebook. So we'll be implementing now. We'll be doing a code. Yeah. I think I last time I shared database link with all of you guys. I'll share once again. Just give me a minute. If people who have joined today only, so they'll also get an access. Just a minute. Okay. So this is a link again I'm sharing in chat to everyone. So please download the dataset from the chat, so you will able to perform the code that we are doing right now. Okay. So this screen is visible now, everyone. The Jupyter notebook is visible, I hope everyone. So new. So I'm renaming it as a logistic regression, and we'll start with the implementation. So basically, first what we'll do. So I hope everybody is ready. I hope everyone opened their Jupyter notebook and they have already done their data. So I'm considering everybody is writing a code simultaneously with me. So what we'll do, we'll try to implement very simple. We'll generate a random data, and we'll try to build a classification problem on that using binomial classification. Binomial classification using logistic regression. Okay. So first, if you remember that we have to import some necessary libraries that we need to execute code. For example, we have one library, NumPy. Import NumPy as NP. Then what model we are going to do? We are going to do logistic regression. So for logistic regression, we have to import logistic regression from sklearn library. Sklearn dot model selection. Import sklearn dot linear model. Import logistic regression. Okay. Second, before training a model, what we have to do? We have to split the data into train and test sets. That's we already saw in our last case that we implemented with linear regression. So from sklearn dot model selection import train and test bed. Okay. So now we are not going to use any sort of data set from anywhere. So what we'll do, now we have already familiar with the NumPy and pandas. So what we'll try to do, we'll try to generate a random data using NumPy, and then when we'll move towards multinomial logistic regression, then we'll be using a data set. So what we have to do now, if we have to generate a random values, generate a random data for binary classification. So we have X variable. So we have a data, we have a function in NumPy that is np dot random dot ran, which will generate a data with the shape of 100 by 1. And then we have Y. We have to generate a data for target column. So this data will not make any sense to anybody because it's a random data. It will, every time I'll refresh this console, it will generate a new sort of data. For that, we can use a random seed and int. So we need to have two classes. So we have to set a range from 0 to 2, and how many records we need? 100 records. So also there is one more technique that I want to show. If I'm using certain function, and if you don't know what this function is, what you can do, you can type here np random dot ran, and you can place a double question mark in front of it, and you can execute that. Just thing. It's not working here. Okay, I think it's not working here. So I'll show. Then what? Now we do have a data. We have a x. We have a x data set. Then we have a y data set. We have a x means our dependent variable. Y is our target variable. Our independent variable. What is the difference between dependent and independent variables? Independent variable is a variable that we are going to predict, and dependents are the variables from which the value we are going to dependent variables are the variables or the features or the columns available in a data set which will decide or which will help us to predict our independent variable. So we have to do a train and test split now for data. Then there is a basic train x test, then y train, then y test is equal to train and test split. We have x and y, then our test size will be 0.2. So now right now what we did, we divide our data into two parts. So our training columns or training variables will be holding 80% of our data, and our testing variable will be holding 20% of our data. So our model is going to learn from 80%. It will find out, it will generate a patterns from 80% of data, and we are going to test those patterns on 20% of data. That is what the basic meaning of this line. So now we have done with training and testing splitting. Now what we'll do, we'll build a classifier, and we have already imported classifier, which is logistic regression. And now we have to submit our model for training, for classify for if whenever we want to train a model in classical machine learning. So we have to use a method called fit method. So now what we are going to fit with classification, we are going to fit a training data. We are going to submit a training data to this fit method. Now what is our training data? We have already mentioned, that is X train and Y train. X train and Y train. Yes. So let's see. Let's train the model now. It's a small model, so it will take a fraction of a second. Okay, it's done. So now we have already trained the model on this data set. If you want to print the data, so you can see what is the X and Y. So this is our X, some random variables, and this is Y. This is why every variable will be a 0 1. It's a binary classification. Every records, that is 100 records available in X. So every records will have some random target column, and this data. so for example, column number 0 will have some value 0.5961, and its target column, that is independent, or its classifiable label is 0. Second column has 1, another column has 0. This is randomly generated data. So this is your X and Y looks like. So now we have trained the model. Now we are going to see how our application, or how our model which we have trained is going to perform on test data. Test data is always unseen data. So we will able to calculate how it's we will able to calculate the accuracy of our model and its patterns, how they are going to behave on unseen data. So let's write a code for that. So we'll write our prediction, that is our Y prediction, Y hat or Y prediction. Now we have model, we have train model in this variable CLF, now which will having a function called predict on test data. Sorry. Forgot to. Let's see. Okay, these are the results. Yes, this is not making any sense. Let me print the predicted class and actual class, then you'll get understanding. So we'll do one thing, print predicted class, that is Y print actual class, that is Y test. So this value, the length of the array should be 20, because we have 20% of data for the testing. We kept 20% data for the testing. And what we need, we also calculate, we will also calculate accuracy. So accuracy will be something like this. CLF classes will be having the function called score, and accuracy will be measured by comparing two variables now. Which two variables? One which is predicted by algorithm, and one is a true value. Or what are our true value? Our true value is the data which we have already, which is a X test now. And what is the predicted value, which is Y pred, that we already got here. So how will we calculating a score or accuracy of algorithm? We'll pass this two value, which is X test, that is our Y true, that is our true value, and our predicted value. and we'll print the accuracy. Okay, let's see the results. Okay, accuracy. Oh, sorry. Okay, let's see the results now. Now, if you compare our actual value was 0, but predicted is 1. If you compare our second for the second record, our actual value is 1, our predicted value is 0. For third, 0, 0. Third is matching. For the fourth, it's not matching. So this is what a binary classification will looks like using logistic regression if you are trying to perform. Now there are certain case studies available where you can actually use, for example, if somebody have a cancer or not having a cancer, then I'll suggest some of the data sets so you can perform a binary classification. So this is what a basic outline of binary classification, or this is how you can implement a logistic regression. Now what we are going to do after this, we will be implementing a logistic regression on a data set called iris dataset, which is a very go-to data set for when we start a classification or any sort of machine learning classical machine learning algorithm learning. So these are the data set, MNIST data set, iris data set we use as a go-to. So what I'll introduce first what is this iris data set. I hope this iris data set. Okay. Vishal, this Google console is visible?
Yes, sir, it's visible.
Okay. Yes. Okay. This is the image. Okay. So you can see this image here where 3 flowers are there, and one is iris setosa, one is iris versicolor, and another is iris virginica. So these are the 3 flowers which looks if you saw them from a distance, they almost look similar, but they have certain differences. If you observe, the shapes of their petals and sepals are different. So what we are going to do, so this is, we do have a numeric data available where we have a sepal length, petal length for this iris setosa, then sepal length and petal length for versicolor, and same attribute for virginica. Now what is our task? This is multinomial because we have 3 classes here. Now basically our task is to detect whether the new records which belongs to this particular data set, if they comes and or if a user submit those records to our algorithm, now algorithm has to predict whether the particular records belongs to setosa family, versicolor family, virginica family. So this is a basic outline of this data set. Now before learning a data set, what we have to do is let's read the data set now. So the link that I shared with you, all of you, it also contains a file that is iris.csv. If you are doing this implementation side by side, then please download that dataset in your folder where you are performing all this, where you have executed Jupyter Notebook, or people who are using Google Colab, please do upload that file in your Google Drive. And I have already showed how to mount Google Drive in Google Colab and how can you access a dataset. So because we have already implemented that code last session. Now let's understand the dataset now. So how we so before understanding dataset, let's import some of the libraries that we will be needing for performing a data analysis and implementing logistic regression, so we can understand our entire data set and what are the applications we have to perform, because we are going to use the same data set, similar kind of data, this same data set for KNN as well. So after implementing this, I'll explain KNN and we'll be extending this same Jupyter notebook for KNN as well. So warnings. These warnings are for the whenever there is a changes in certain libraries, then it while executing a cell, it throws some warnings. So if you don't want to have those in your Jupyter notebook, you can use these functions and these lines of code which will avoid unnecessary data in your Jupyter notebook. We need a pandas for reading data frame or reading data sets, so we can convert our CSV file into a data frame. For plotting, we need a matplotlib dot pyplot as PLT. Yes, so we have to import magic function for matplotlib inline. Then another plotting visualization library, Sigmoid as SNS, and we'll be setting us. Oh, we don't have to set style. We'll set top. So exhibit. So here. Morning. It's warnings. There are certain typos. Again, model warnings, filter warnings. Okay, it's done. Now our next variable is what we have to do. Our data now. We have function call. Now PD is what? PD is an instance of our pandas that we have created now. So PD dot read read CSV, because we have our data set in the form of CSV. So and having a name iris dot CSV. So this is how we read a data set from CSV file. Now, if you want to see what is the content in our iris.csv file, what you can do, you can print. See. Okay, so this is how your data set is looking now. So you have an ID of a record, you have a sepal length in centimeter, you have sepal width in centimeter, you have petal length in centimeter and petal width in centimeter, and your target and your target variable is spaces. Spaces, you have 3 spaces that you already aware about now. Setosa, versicolor, virginica. Head is a function which will retrieve first 5 values from the dataset. If you want to see an entire dataset, you can just go with data. So it will print, it will show 150 rows that you have in this particular dataset. So head will, it's good for presentation because you just have to get idea of your columns and what kind of data available in the dataset. So now we have to understand what is the information and what is the details of our dataset. So we know the function now. We have one function called info, which will give us an information that we do have 150 entries in our dataset, ranging from 0 to 159. Index are 0 to 159. Having a 5 columns, 1, 2, 3, 4, 5. Sepal length and width and petal length and petal width in centimeter. And the 5th column is spaces. Every column will have 150 record and every column is non-null. So basically, also you have to understand, as we discussed while implementing linear regression, that linear regression, while implementing linear regression, it's the difference between Panda, NumPy, and Matplotlib. Okay, so Pandas is basically a library we use to read a data or perform an operation with data. NumPy is a optimized, for example, you perform an array operation. So NumPy is a library that has been optimized by using a vector operation. So it takes a less computation power while executing any sort of array manipulation. For example, matrix multiplication, if you are using, so what you can do if you want to check what actual difference NumPy made, So what you can do, you can create a list and you can perform a array multiplication by implementing a simple logic. And what you other thing what you can do a same operation using a numpy methods. You will find a certain difference between both the execution time. Now you have to use a percent time variable which will return a execution time of both the program. So you will understand it makes a difference between so numpy will use the less resources and give you a faster output. You won't feel the difference in both the operations because the operations will be getting performed in a millisecond. So you won't get an idea. But if you actually print a time of execution for both the function, you will see a difference. So this operation will make a huge difference when you are performing and you are performing a large operation. About matplotlib, so matplotlib is a visualization library. So I'll tell you what kind of visualization. So these data points are there. So basically what you are understanding from this data point, you are not able to generate any sort of analysis from this data point. So as a human brain will understand uh, will understand or will comprehend things more beautifully or more concretely through visualization. So if we try to visualize this entire data set, so what we'll do, we'll understand and we'll generate some analytics from it. So now what we are going to, so we'll try to we'll try to plot something from this data. So before moving to the plotting, we are going to do one more pre-processing steps. So there is one standard for whenever you are trying to solve any sort of machine learning. So you whatever the column names and target column names you have right now, so you have to rename them. You have to make them simple and you have to make them understandable. And while executing or while implementing a further code, they will it make them readable. So what we are going to do, we are going to rename these columns in a different way. So for that we are going to write a code. So these all are pre-processing steps that you will be facing or you will be using in multiple uh, use cases where the data generator or data scraped from the mm, your clients will be not in a very good form, and you will not able to search. Sometimes you will not able to relate with the column names, so you have to rename the columns from your own understanding. So that time this kind of data processing steps that you have to take care of. So what we'll do, so we have a data and we will use the rename function. We do have to mention all the columns that we have. So we have a, okay, let's copy and paste so we don't make a spelling mistake. Okay. So what will map it as a small letter. Always remember all the column names should be in small letter. These are the standard. Okay. This one is done. Then next is staple width. Next is petal length, and we are going to rename it as petal length. These are very necessary steps because sometimes what happens if your code or if your analysis is not readable, or because you are going to share it with the third person who hasn't done any coding, so he should also able to understand what you have done. So that is why always generating a readable format code is very important for any sort of any developer. So this is why these steps are necessary. Wait, last column we have is spaces. We just have to put it in. We just have to convert it to small case. Okay, let's execute this. Okay, there is an error. Typo. Yeah, let's check our data set now. Data dot head. Whether our column. Yes, if you can see, I think our last column name hasn't changed. What is the problem with that? Hmm. And now it's done. So let's check data dot info again. Yes, all the changes have been done. Now, how many classes we have that we know? We are already aware about. We have 3 classes now. That is space. I already show you how to count a unique values from a particular column. Now we have how many categories we have for this spaces value? How many categories we have? We have value counts function for this. Okay. So we do have a 150 records that we already know now, but we were not aware about the fact that uh, the data, the Setosa flower belongs to, like, 50 records belong to the Setosa family, 50 records belong to the versicolor, and 50 belongs to the Virginica. This implies that what is the analytics this data is giving us? That this entire data set is balanced data set. What is the definition of balanced data set? Balanced data set is the definition of balanced data set is that the number of records available in the data set, if they are equally belongs to the certain classes. For example, you have a 2 classes and you have 100 records. If 50 records belong to class 1, 150 records belong to class uh, 0, then it's a balanced data set. What is imbalanced data set? Exactly opposite. For example, 80 records belong to class 1 and 20 records belongs to class 0. So that is imbalanced data. So now the person who asked me what is a what is the functionality of matplotlib? So we will be plotting a 2D scatter plot using matplotlib, which is a visualization library. So you will get a perspective of what are the advantage of plotting data and what is the advantage of visualization. What kind of plot we are drawing? We are drawing scatter plot. On our x-axis, we will be do sepal length and and our y-axis will do a sepal width. Okay. PLT dot show method will show us a graph. Okay. Oh, so this is a graph. This kind of graphical representation you can get from the matplotlib. Now, if you are observing this graph, what you are understanding? Like everything is on a similar color, so I think we are not able to build any analytics out of it, because we have a 3 flowers. So it could have been better, I think, if the 3 flowers had a 3 different colors, so we could have I think we could have observed data more beautifully. So what I think, we do have another library. We have imported or not? Yes, we have imported seaborn and SNS. It's an another visualization library which is more advanced. So what we'll do, we'll try to build a great data. We'll plot here scatter plot using matplot. Scatter. GTS. Paper. And we also have to add. Let's see how much, what's the difference. Okay. Now, if you observe, so what we have done, we have added, we have used a face grade function from Seaborn library, which added colors for our species now. So Iris setosa is represented by blue color, orange color is representing versicolor family, green color is representing Virginica family. Now, what kind of analytics you can draw from this graph? That if you are using a linear regression, what you could have done, you could have simply draw a line from here to here, which could have make a classification very easy and 100% with 100% accuracy between setosa and versicolor family. But if you see versicolor or virginica, if you see this data is little bit overlapping here. So what we can do, the way we have plotted a petal length and sepal width, so what we can do, we can this yeah, so we have 4 variable now: sepal length, petal width, sepal width. So what we can do, we can plot spaces, all the spaces with respect to all those 4 columns. So instead of plotting one by one, we'll plot in a single graph now. So we do have so what you can do, whatever analysis. So usually I suggest that if you have found something, if you have found some valuable readings from by reading this graph, you could comment here, or you can add one markdown field here, and you can observations from these plots. Then first observation is that blue points are easily separables. So this sort of observation you can write. There are other observation like from red and green. You can draw a line between red and orange and green plots, and orange and greens are a little bit overlapping each other. So this sort of observation you can write here. Now what we do, we'll try to plot spaces with respect to all 4 columns. So instead of plotting one by one, it will save a lot of time. So a lot of time. So again, the code for that is, so we have to set a style first. If you are using, so style means that if you want to grade, whether you want to grid or not while plotting. So these are the formatting techniques that you can find on Seaborn documentation. You just have to Google Seaborn and check the documentation. You'll find all the attributes. Pair data. What is spaces? Let's see what it's what analysis we get. Running. Yes. Okay. So if you can see, this is the graph we got now. So on x-axis, if you say we have ID, sepal length, sepal weight, petal length, petal width, sepal length, sepal width, petal length, petal width. Now, what kind of observations you can generate from this particular graph? If you are able to read, you can see, you can find out what is from. Okay, if you see this top right if you see this top right graph, you can see all the three variables, all the three flowers are separable. Then another observation that petal length and petal width. We'll do petal length. Where is the petal? Petal length here and petal width. Okay. Okay. This is also almost separable, but you can see this here little bit overlapping is there. So now you have to read the graph and you have to come up with your own analysis for this mm, sort of plotting. So this is the function of matplotlib and uh, C1 libraries. So now we have done our analysis and we have learned few things from this, that what are the columns important. For example, petal and petal width are going to help us to draw a classification line or draw a classification outcome from a data set. So next is what we have now. So last, if you remember in last session, we had one column which was a categorical feature, which was ocean proximity, I think, if you remember. So to convert that column into the form of numbers, we use a one-hot encoding technique. So that was a one technique that we discussed. Now what we are doing to, we have one, like if you observe, if you check our data frame, that our species column is again categorical. We have three categories: Setosa, versicolor, and virginica. So now what we have to do, we have to map these three categories into numbers. Last time we used one hot encoding. This time we'll be using a very simple dictionary mapping technique. What we are doing to, we are going to convert categorical features into numbers. Now, what are flowers are? Sorry. Okay, stick. Okay, our flowers are. We'll avoid a spelling mistake. Okay. So our flowers are. So first flower is Iris setosa. So we'll be mapping. We'll be mapping this first class as a 0, second class as a 1, and third class as a 2. So this will be our 0, then versicolor is our 1, and virginica will be 2. Now what we have to do, we have created dictionary. Now simply we have to map this in our data set. So what column we are mapping, that we have to remember, we have mapping a species column. In species column we have to replace values of species, which is a column name, to the way that our flower mapping dictionary is there. So let's see. Okay, it's done. Let's check our data now. Data.head. Okay, good. You can see the first 5 records were Iris setosa. Our mapping for Iris setosa is 0. Now your first 5 records mapping with respect to your setosa was 0. Now here is also 0. So this one preprocessing steps we have accomplished. Now we have done almost all the preprocessing. What we have done, we have renamed the column names. We have converted our category features into number. Now what is the next step? We have to Just a minute. Give me a minute. I think left discharge. Give me 2 minutes. Okay. So now we are almost done with resource thing. Now what we are going to do? We will be doing it the way we did here in our binomial or in our binary classification. What we did after doing entire data thing, we classify. We split our entire data into train test split. Then we build instance of class logistic regression, and we pass our training data. So similar steps we are going to follow here now. So what you have to do from we are going to train test split first. Okay. Train test split. So from scalar dot model preprocessing, so model selection, import train test split. So our x-axis is equal. Our x where x will hold the data, all the columns besides only excluding species column, because this is what we are going to predict. These are our dependent variable, or these are our features, okay, from which we are going to predict our species. So for that, what we have to do, we have to assign enter data, but only we have to drop a column which is a species. And what is another attribute? X is 1. What is the x is 1? X is 1 will be dropping entire column. If x is 0 is there, so it will if you have to drop if you want to drop a row from the data frame, then you use a x is equal to 0. If you want to drop entire column, then you use x is equal to 1. Now this is your x. Now what is your y? Your y is spaces excluding everything, only spaces column. What is that will be your target column. So you can directly assign your y spaces. So this is your x and y is ready. Now I want to type again and again. So what we'll do? We'll copy this entire line and we'll put it here. So x train y test is equal to train test rate. Your x variable is this. This is your y variable, which is species column, and you will be doing 80-20. 80-20 usually you can do 70-30. You can do a 60-40, whatever you want. But 80-20, it's pretty standard, or everybody prefer to do 80-20. Let's execute the. Yes, okay, it's done. Let's check the shape of your train and test. So it's 112 records by 5 columns. It has, so your training is like 75%, which has 112 records. Other 38 records will be in your test sets now. So your test should be 38 by 5. Let's check that. Okay, correct. So we have done everything correctly. Now we have to create an instance for our model. For that, we have to import a model from linear model, logistic regression. Okay, create an instance for our model classification model LR is equal to logistic regression, then model LR dot fit. Now what we'll do, we'll fit, now we have to train. Now what kind of data we submit to our model? A training data, which is X train, comma, Y train. So let's execute this cell. Yes, successfully it has created a model. Now what we have to do? We have already trained our model. Now we have to check accuracy or what is the score of our model. Usually the score of our model on X test and Y test is sorry, it's a model LR. Oh, it's 100% accurate. Okay, so so there is a reason. So another two concepts that I'm going to introduce right now. So because this model is giving us 100% accuracy now, so we are going to discuss that right now. So let's check the predictions on testing data. So for that we write when we data binary classification. Predict test. Wow. So these are the outcome that we are getting for the 38 fields that we have. Now, if you want to get a similar kind of observation that we have done here for this, that also we can do. We can map them actually. Okay, these are the predicted class and these are the actual class. These are the ID numbers, so please ignore them. These are the these are some error, I think. Oh, this is okay. Now it's done. So now we have to map it one by one. So that is another very tedious task. So this is what a basic outline of logistic regression. So now what yes, now what I now here the algorithm accuracy is showing 100%. So now there are two concepts that I would like to introduce here. One is overfitting and another is underfitting. So what is overfitting first? So 100% accuracy in a machine learning is considered as a myth now. So it's very difficult to build a system which will give you an 100% accuracy, uh, which will give you an just a minute, please. Uh, which will give you an 100% accuracy. So what is the overfitting? So overfitting is a basic machine learning phenomena where your model will train or model whatever training or whatever learning your model will do from the training process. It will learn from that data too well, and it will become very generalized. That is what basically I'm trying to say. So whatever input it get, so it will perform 100% accurate on training data because it has seen that data. But whenever you submit a test data or unseen data to the model, it will perform poorly on unseen data because it and so let's do one thing. Instead of putting emphasis on these two concepts right now, so there are other two concepts we are going to need, that is bias versus variance, bias and variance. So we'll be learning those in our KNN anyways. So I'll be explaining these two concepts there as well. So this is what we have done with logistic regression. Now we have to finish our k nearest neighbor. That is another algorithm, another classic, another machine learning algorithm. So I'll be doing that right now. So I hope you got basic idea of logistic regression. So now again, let me share my. Okay. So now okay. So KNN stand. So new algorithm that we are going to see is KNN. That is K nearest neighbors. Okay. K nearest neighbor. So KNN is an algorithm just like linear regression and logistic regression. KNN can be used for classification as well as regression. Now, how we are going to use this algorithm in terms of classification and regression that I'm going to explain you. Before moving to that part, we'll understand how KNN works and what is the basic idea of K nearest neighbor. It's a very simple and easy to understand algorithm. It's not complicated. It does not involve a lot of mathematics as well. So basically, on this graph, you have a data point belong to certain class. Okay. You have another class. Okay. Now, when when you give now this is your data set. Now when a new data points comes, this is we say class 1, this is class 0. Now when a new data points come, so it will be somewhere, it will directly be somewhere here. So this triangle is a new data points. Okay. Now how we are going to identify that this triangle belong to class 1 or class 0? Okay. So as name itself indicate, K nearest neighbor. So there is a value of K. For example, K is equal to 5. Now how this value, how we came on this value, it will be decided by hyperparameter. This is value of the K is one of the hyperparameter. Okay. For this class, sorry, for this algorithm. So if the value of K is 5, don't worry about how the value of K is can. We'll understand later. So now if you observe beside this triangle, or what are the neighbors, what are the 5 closest neighbor of the this triangle? So you can see this cross is there, this cross is there, then this 0 is there, this 0 is there, and this 0 is there. So basically what we have got, we got two value from class 1 and 3 value from class 0. So now another question arises, that how we find out that these 5 points were the closest to this particular triangle, which is a new data point. So there is a formula for it. So what basically we do, we calculate a distance of this particular new data point with respect to all the nearest neighbor to it. Now what is the definition of all? That is the value of K. Means we calculate the 5 nearest point with respect to this particular from this triangle. So now what is a so there are multiple there are three I think there are two or three types of distance calculating formulas that used by KNN. First is known as a Euclidean distance. Okay. So, and second is Manhattan distance. We will be using Euclidean distance for now to solve this problem. So what is Euclidean distance? So when on this graph, so this is your point x1, y1, this is your point x2, y2. Now if you want to calculate a distance, if you want to try to calculate distance between these 2 points, distance between these 2 points, so you understand that basic formula we have for the distance on a graph paper. So what we do, so according to Euclidean distance, what it do? So you know this is the what is the property of the this what is the formula to calculate the calculate the length of hypotenuse? So it will generate a formula just like this: square root of x2 minus x1 bracket square plus y2 minus y1 bracket square. So by using this formula, we are going to calculate a distance between all the points. So now there is another question. So what if so every time a new data points comes that you are going to calculate, you have to calculate the distance from that particular data points. You have to just a minute. Yes. So every time a new data point comes, you have to calculate a distance from this distance for this particular data point. So now, so it makes this algorithm computationally expensive if there is a large number of data points available in your system or in your requirements. So this is very basic and fundamental understanding of k nearest neighbor. Now, what are the applications of it, and what are the disadvantage of it? So basically, k nearest have been usually used in if you are aware about the corpus or the text data, and if you want to find a concept, if you want to find a topic searching which are similar to certain topics, then we use a k nearest neighbor. Then there is another recommendation system. If you want to build a basic recommendation system, then also k nearest neighbor is usable. Now, this is simple algorithm, but there are certain disadvantages and limitations to it. So if there is a huge data set, then this algorithm might not work because it has to store all the distances from the all the distance from each point to generate a results for us. So that is computationally expensive as well as storage intensive. You have to store everything every time. Second, if there is an outlier, now what is the outlier? So outlier is basically a concept. For example, these are your data points. These are your regular data points. Okay. Now there is one data point here. So the data point which away from the normal or regular data points called an outlier. So how KNN is affected by outlier? So if uh, so if you are trying to build the nearest neighbor and your variable your point is here, now this point is outlier and your new point besides here. So now definitely your new point is belong to class 1 and this is class 0. So your new point will calculate the nearest distance. Now this one is near, this one is near, this one is near, this one is near. So sometimes what happens, this outlier will be a decision maker for classification. So that is why it might affect your outcome. So this is what a basic classification idea for k nearest neighbor. Now we have when we started, I told you that it can be used for classification that we have already seen. We can also use KNN for regression problem. Now how we can use a regression problem? Let's see. Again, take an example of prediction of housing prices. Now you have these data points everywhere in your graph. Okay. Value of your K is equal to 5. Now in classification we have in classification we have voting system. Okay, we are finding number of neighbors from we are counting number of neighbors belong to certain classes. Voting system, just in simple term. In regression, what we do? We do average. Okay, so what? So if we are trying to predict the price of an house, so what we will do? So for example, these are the houses. This one house price, this is another house price, this is another house price, this is another house price. This is for $1 million, $1.5 million, $2 million, $1.75 million. Now your new data points comes here. Okay. Now the value of K is 5. So what? So how the price of this triangle or new data point will be decided? It will take an average of all these 1, 2, 3, 4, and 1, 5. All these 5 data points, and it will find out the average. It will add all the points, 0.1 plus 0.2 plus 0.3 plus 0.4 plus 0.5, and it will find out the average of that will be the price of your house. So this is how you can use a k nearest neighbor in regression as well. So this was the basic idea of k nearest neighbor that we have. So let's see a quick implementation of k nearest neighbor using scikit-learn. We are going to use a very similar Jupyter notebook that we used for logistic regression. Just will leave some columns. I think it's k nearest neighbor. KNN. Okay. Just Okay. Now you don't have to do all this analysis that we have already done. Okay, because we are trying to solve a classification problem right now only. Okay, so what we have already done, we understood the data set, we know everything now. So what we'll do right now, we will be writing a very simple code, the way we have written here in yes, for logistic regression. We already have train and test split, so we'll be using a similar code. So now what we have to do is we have to import k nearest neighbor from your sklearn libraries. So from sklearn dot neighbors import k nearest neighbor classifier. Okay. So what we have to do, model knn is equal to, I hope you are understanding that we are not doing all the pre-processing and everything because we have already did for logistic regression, and we are using similar Jupyter notebook. That's why we don't have to do anything right now. Model knn k nearest, sorry. Now the value of the value of neighbors is depend. It's consider right now because we haven't covered a grid search CV or random search CV, which we will use to perform hyperparameter tuning. So this, consider this value right now experimental. Usually what we do when we do hyperparameter tuning, we do we pass a list of values. For example, from 1 to 11, take all the values of n neighbors, and whichever value will give us the highest accuracy, will use that value as a neighbors, or that value will be considered as a neighbors, number of neighbors. That we will be doing while implementing grid search CV and random search CV in when we move forward. So right now we are considering n value is equal to 3. So we have model, and we have created an instance of our model. Now what we have to do, we have to train our model now. What data will train? Will be using X train and Y train that we have already created above. Let's execute this cell. Okay, our model is created now. Let's check a score for our model. Model KNN dot score on your Y test, sorry, X test and Y test, which is your unseen data set. Again, it's an 100% accurate data set. So now it's important for us to introduce bias, variance trade-off, and overfitting and underfitting concepts. So again, let's check, and Y predict is equal to model knn predict X test. No. So we will be saying one thing that also will help us to read this entire data is there is one more what visualization is available in the form of confusion matrix. So what we'll do, we'll try to plot a confusion, or we'll try to get a confusion matrix from it. I'll explain what is a confusion matrix in a bit once we plot it visually. Print matrix of y from yes. Okay, this is the confusion matrix. For example, all the precision recall and F1 scores and accuracy is 100%. For example, you have given 38 records to test this model accuracy, which were unseen data, and it has predicted all the 38 records accurately. So it's doing pretty well. But let's see how what is outcome and how we can make it more readable using or matplotlib by plotting this confusion matrix. I'll also show you how to read a confusion matrix, so it will easy to interpret everything through visualization. That's why all this that's why getting an hands-on experience on Seaborn or matplotlib kind of libraries is important. So you can visualize everything. Annotate will help us to put values on our graph. Annotate means annotation. So it will put a column names, and it will help us to draw conclusions that or it will help us to identify which column is representing what, and this is format, which is called or x label will be x-axis will be predicted levels, and or y label row levels. PLT dot version. Let's see if it's wrong. Okay. So now, so this diagram is representing similar data that we have represented here, or this plot is representing similar data that we have uh, presented here. So now what it's saying, so total we had 38 records, that is 15 plus 12 plus 11, which is 38 now. So for class 0, true labels were 15. Okay, and class 0 true predicted labels is also 15. So this is 100% accuracy. This is making it more readable. So I'll do one thing. I'll make some changes in the record, so you can see the more accurate confusion matrix, or the confusion matrix which is making some with some I'll I'll get you another confusion matrix that I did while This coding. Okay, if you can see, so forget about this constraint matrix. Check this another constraint matrix, which is new. And so if you can see here, it has here it has predicted 11 correct results for class 1. Okay, and if you can see 0, and it has a 11 result for class 0, which was I think Setosa family. But there is one mistake it has done. So even though the class was even though the record was belongs to class 0, it has predicted it as a class 1. So this is how this kind of readability or this kind of understanding that you can get from confusion matrix. There are so again I think there are the certain concepts like true positive, false positive data, true negative data, and false negative data. These so basically, constraint matrix is a combination of all these. Uh, I'll share one more diagram so you'll get a better understanding of constraint matrix. Okay. Yes. Right. This image will give. Oh, yes. Yes. So this is a constraint matrix now. So this is a positive, negative, actual values, predicted value. These two are the classes. These two are again classes. Now, what is TP? So TP means a true positive values. That is, the model correctly predicted a positive class. Okay. So the actual value were the positive and the predicted value was also positive. So these are the true positive values which are mentioned here in confusion matrix. Second one is false positive. So the actual value, so model incorrectly predicted the positive class. Actual value was a negative, but model when it did a prediction, it predicted a positive value. So this cell is represented by this value or this false positive definition. What is false negative? These are really confusing. These terminologies are really confusing. But if you want to understand the confusion matrix and if you want to understand the matrix and how to evaluate models to confusion matrix, you have to understand this. Once I think I'll add the definition also in this notebook and I'll share with you. What is false negative? So false negative is the model incorrectly predicted it's a negative class. So the actual value were the positive, but when the prediction happened, these are the actual values. Actual value of this class is positive, if you can see here. But while predicting, what model did? It negative. Model predicted negative. So this is uh, false negative. False negative bracket. Now what is true negative? The actual, it's similar like false true positive. The actual value where was a negative and the predicted value is also negative. So so basically the confusion matrix will summarize the outcome of all these columns, or confusion matrix will summarize the counts of all these outcomes in a particular uh, uh, in pictorial form, or you can say in the form of plots. So it's easy to understand. It's easy to understand data. So usually this is this you are seeing here. I'm using this 2 by 2 confusion matrix here. It's just because it's easy to interpret and easy to understand. It's for a binary classification. We have 3 classes here. That's why we have 3 by 3 columns, 3 by 3 confusion matrix here. So yes, so this is what the confusion matrix is. Now the remaining term we have remains remaining terms are, now we have to see bias. Second is variance. Third is overfitting, and next is underfitting. So let's see. Okay. So let's see what is bias first. So I'll orally explain you what is bias now, and when we'll come across the situation while performing or while implementing a code, and then we'll see how programmatically we can identify that this particular algorithm or this particular model resulting in bias. So basically bias is basically what uh, so what are the outcome that your machine or your algorithm is generating. uh, um, let me try to put it in the simple terms. Yeah. So okay. Basically, what model is predicting, if the values that are model is predicting are too high or too low. For example, they are not somewhere around. They are not going parallelly with the values that model is predicting. They are somewhere away from the predicted value. For example, they can be plus 100 or they can be minus 100. They are away from the predicted value. Then basically considered as your model as a bias model. For example, if your model consistently trying to predict the higher salaries of men than for women, then you can say that your model is basically biased against women, because it's trying to favor a one class. For example, when model is performing very good or very for example, it's giving a 90% or 95% accuracy for a one class, and it's giving only a 60 to 50% accuracy for a single class, then you can say, or you can generate a statement that it's again depends on the what kind of data you have submitted to the model. What general statement you can generate from this situation, that your model is basically biased toward class 1, because it is not making a very good predictions on other classes. It's only it's only predicting a good outcome for a particular class. Then you can consider, or you can say basically your model is biased. And now that is why whenever we submit a data, or whenever we feed the data to the machine learning uh, model, then it's necessary to understand that the data should be balanced. It shouldn't be imbalanced. If your 80% records are belong to one class, or 70% records belong to another class, then what will happen? Your model will generate a bias out of it. It will work very well on one class. It will not work very well on other class. So what it's doing? So to avoid such things, there are certain techniques available uh, of which we call the data augmentation. So in data augmentation, what we usually do, we create a similar kind of values. So I'm more aware about data augmentation in images. For example, I'll give you an example of image now. So what we do, if we have a certain image in machine learning, and we are trying to classify that image, and we want to feed now more data to the machine learning model, but we have imbalanced data. For example, we have 100 images for a dog class, and we have 20 images for cat class. Now what we'll do, we'll try to augment data. Now augment, what is the we'll try to augment means what we are going to do, the 20 images that we have right now, we'll try to flip some of the images. We'll try to add some filters into it. Filters in the sense we'll try to change the colors of it. We'll try to make them grayscale. So this is how we'll try to increase that 20 data points to somewhere around 100 to 80 data points. So which will make our data balanced. And so also we also have to take care of the fact that whenever you try to augment data, don't overdo it, because it will create again bias against another class. So there are lots of possibility again for this bias phenomena. So this is basic understanding of bias. Again, we are going to see. I'll try to put it in a problem in whatever implementation that we are going to in next session. Now, what is variance? So it's variance is refers to the sensitivity of model prediction, and what is the small fluctuation that happens in training data, or model with a high variance may fit a training data very well. Like it will do a learning very well from the training, but it will not give outcome on the generalized data or unseen data. So high variance may be representing overfitting. Overfitting means what I already told you, that your model will try to generalize things. It will try to generalize things in a way that it's know everything, and it will show 100% accuracy on training data, but when you submit or you feed unseen data, it will show very poor results. So that is what uh, variance that is due to high variance in your model. Now, what actually means overfitting, or what actually why this variance occurs in your model? So in learning process of your model, if your data contains certain amount of noise in the sense the variables which are not now whatever analysis we are performing, it's very clean and pre-processed data. That's why we are not facing any sort of problem. But when we are when we work on real-time case studies or real-world case studies, we scrap a data from internet most of the time, and we don't even have a data for certain fields in our data sets. So that time what happened, lots of data, there are certain pre-processing techniques available. Either we remove all the columns or all the rows which does not have values from our data set, or what we try to do, we'll try to fill those null values by the value of by averaging the column value. So for example, if you have a 10 if you have a 10 rows, then you will calculate and if you have 10 rows and for a columns, then you will for a columns you will calculate the average of all the 10 rows, and you will fill the value of that. You will fill the average value to the columns where there is null value. So this is not a, now you understand, this is not an actual value. So so there might be a chance that algorithm in the process of training, the algorithm will consider this value as a noise, uh, as a noise, and it as a noise, or there might be a chance that algorithm will take it as a good, and it will generate a very good and proper results from it. It depends again, it's experimental, that what patterns algorithm is learning. So this is how the things will affect, or this is how the high variance will put your model in overfitting. So now on the other hand, now what we have done, so if your model has a high variance, uh, and instead of learning patterns, or instead of building a relationship on your data, if it's trying to correlate everything with a noise, then obviously you will get a low accuracy and poor performance on new data. So that was due to high variance. Now if you have a low variance in your model, means you will be uh, sorry you will be underfitting your model. So exactly opposite of what overfitting does. Meaning, what does it mean underfit? Meaning, now in overfitting, what your model was learning things extremely well. Like it was after identifying patterns and relationship, it's trying to build a relationship with noise data or data which is not useful, or it will trying to build a patterns which will be not useful for predicting our outcome. So now exactly opposite. Uh, in underfitting, your model will be very simple. Okay, your model will be very simple, and opposite to overfitting, it hasn't understand, or it hasn't got so many patterns or relationship to the data that we have submitted to it. That will be a, so again the performance, it will affect on your performance. You'll get a low accuracy on your data. So overfitting is also bad, underfitting is also bad. So there are the techniques, there are techniques available to reduce overfitting and underfitting. We call them as a regularization. Then there is a cross validation is available. Uh, Regularization will be learning the regularization when we'll build a very master file, when where we'll be will be doing all, after learning all the algorithms, we'll build one master file where on a very single data set we'll perform all the classification problem by doing cross validation and regularization. Then we'll understand all the concepts. And then there are ensemble technique. Ensemble techniques is another machine learning technique where now for classification what we are doing, we are only using a single logistic regression model, single classification, k-nearest model. Ensemble is something that where we use a multiple machine learning model to solve a particular case study. We'll combine multiple layers of model, and so we can get optimized results. So these are the basic terminologies. Again, these terminologies will come to a picture when we'll perform, because this is something that we cannot know unless and until we understand our data, or data is generated by ourselves. So these are the factors that are affect your outcome of your algorithm, and there are certain techniques available which will help us to tackle what are the problems we are going to face you while building a model or while building any sort of machine learning system. So I think that's all for the today's session, and for the next session, we'll try to cover another classical machine learning algorithm, which will be support vector machine. We'll build one more case study, and so after support vector machine, we'll move to the decision tree, and then after that, we'll try to come up with a master use case where we'll try to do some EDA on very big data sets, somewhere around which will have at least 1,000 or 2,000 rows, from where we can generate at least the basic analytics out of it. And we'll do we'll perform analysis, or we'll generate a results for all the algorithms by tackling bias variance. I'll also try to give an example of how to balance data from imbalanced data. If there is a data imbalancing, how you can do augmentation and everything. So I think that's it. Vishal?
Yes. Okay. Thank you there, sir, for this wonderful session. Okay. Okay. For the faculties, I hope you found this session very beautiful and exciting. I'll drop a message to you, all of you, after this. Give me a feedback about these sessions. Okay. And apart from that, I have interesting news to share with all of you. Yeah. So similar kind of session we are conducting for the students. I'll say workshops for the students. Those will be around 6 to 8 hours, and we are going to conduct them periodically. Let's say today and tomorrow we are already conducting a workshop on Android development. Similarly, we are going to conduct workshops on cloud technology, DevOps, full stack, Android development, machine learning, and data science with Python and 3D printing. So I'll just do one thing. I'll share the link with you. I request all of you to please share this with your student and get their registrations also.